Outlook, Microsoft Outlook email. Yes, the university's email. Okay, if you join Microsoft Teams, please use the university's email. Okay, thank you. Okay, so before we start, okay, just have an idea, okay? Yesterday I was talking about, okay, you can see a pen, but you cannot see the atom, okay? So to give you an idea how big or how small is an atom. Okay, so let's see, this is a coffee bean, and this is a grain of rice, okay? The rice before you cook, okay? So if I zoom in, okay, so sesame seed is smaller. Okay, if I zoom in, you are able to see sesame seed. And then a grain of salt, okay, the salt that you use in cooking, if you ever cook, okay. So you have to zoom in, then only you can see the salt. If I zoom in further, okay, I can see something called a single cell organism, okay, unicell, okay, which is amoeba. And then I zoom in, and then we have paramecium, and then we have human eggs, okay. All these are actually just some cells, okay. And if I zoom in further, I can see skin cell. Okay, did you guys like look at the microscope before? Like do experiments, science experiments where you get your cheek skin cells, okay? So you use the microscope, you can see skin cell. And then you go in further, you have red blood cell. And then it is chromosome. Chromosome is what determines like X chromosome, Y chromosome. What determines whether you are a girl or a boy, okay? So, and then you zoom in further, you have mitochondria. Mitochondria is like the, inside the cell, you zoom in, you will have what we call organelles, okay? So those are the things, mitochondria help to produce energy. So this is even smaller and smaller, okay? Microscopes can't, maybe can't even catch it. And then E. coli bacteria, okay, what causes stomachache? And HIV virus, I believe you guys are familiar with HIV virus. Viruses are very, very, very small. Okay, so here, have you seen atoms yet? Haven't, huh? Okay. And then we have influenza virus. Influenza virus means the virus that causes flu. Okay, and then hepatitis virus, also very small virus. Okay, anything about atom? Haven't, huh? All right. Okay, hemoglobin. Hemoglobin is where you have all your red blood cells together, okay, capture blood, and then the oxygen brings it around. Antibody, okay, we haven't seen atom yet. Okay, so you can see that atoms are even smaller than all of this. Okay, phospholipid and then glucose, okay, glucose are considered as very big molecules. Okay, we finally able to see the large molecule, glucose. And then, okay, water molecule. And then finally, carbon atom. Okay, it's so small, you have to zoom in many times inside, then only you're able to see the atom. Okay, so like I said, it's just to let you know how small is it if you can't imagine. Okay, next. How much is 1 mole? We know the magic number, 6.02 times 10 to the power of 23. But how much exactly is 6.02 times 10 to the power of 23? Okay, let's replace it with donuts. Okay, let's watch this video, just a few minutes.
For donuts. If you had a mole of donuts, they would cover the entire Earth to a depth of 8 kilometers, which is about 5 miles. You really need a lot of coffee for that. If you had a mole of basketballs, you could create a new planet the size of the Earth. If you received a mole of pennies on the day you were born and spent $1 million a second until the day you died at the age of 100, you would still have more than 99.99% of your money in the bank.
Okay, that is how much, 6.02 times 10 to the power of 23. Okay, we know this number, we know it is Avogadro's constant, but how much exactly it is? If you have that amount of basketball, you can create the entire Earth. And if you have that amount of money, okay, you spend every day, you spend 1 million, you still have 99.99% of the saving in your bank. Okay, so just to give you an idea, how big exactly is your Avogadro's constant? Okay, and then next, okay, isotopes. All right. Okay, let's start from hydrogen. Okay, so I will use nature's mix. What is nature's mix? That means naturally. Okay, naturally occurring. How many percent is hydrogen 1? How many percent is hydrogen 2? Okay. Okay, so the purple color represents hydrogen 1. Okay, the purple color represents hydrogen 1. Can you see hydrogen 2 somewhere? Okay, how many? Only one, only one single small green dot, okay, for hydrogen 2. So it shows that in nature, okay, 99.99%, okay, the possibility if you pick an hydrogen atom, you will get hydrogen 1. If you're very, very, very lucky, 0.001%, you will get hydrogen 2. Okay, so carbon. Okay, so you can see the nature's mix. 98.9%, okay, is carbon 12, and then the rest is carbon 13. Okay, let's bring you to the whiteboard for a while. Okay, why am I showing this? Okay, it's actually a bit of a logic. All right, if you have 99.99% is hydrogen 1, and only 0.01% consists of hydrogen 2. So what do you think is your relative atomic mass, your average? Is it closer to 1 or closer to 2? Closer to 1. Okay, that is why you see the relative atomic mass is like that. Okay, it's around 1.01. Okay, let's move on to the second example. Let's say I have carbon. Okay, so carbon 12, I have 98.93%. Carbon 13, I have 1.0%, which is more. 12 is more. Okay, so your relative atomic mass, your average, is closer to 12 or 13. Closer to 12, okay? Teacher, why are you telling this? It's too simple. Okay, remember yesterday in question 3, okay, we did some examples, something like how much is the percentage abundant of chlorine 35? How much is chlorine 37? What's the percentage abundance? Okay, and given the value relative atomic mass, okay, you have chlorine 35, you have chlorine 37, and the relative atomic mass is 35.5. Okay, in relation to what I have explained just now, can you tell me, okay, with the relative atomic mass, what do you know about the percentage? Okay, I don't want the value, okay? Like I mentioned just now, okay? It's closer to 12, so it means that there's more carbon 12, okay? So now, if I tell you relative atomic mass is 35.5, what does it mean? More of chlorine 35 and slightly less chlorine 37. Okay, at least this one, if you have no idea at all how to calculate, at least, okay, this will give you an idea. Oh, my answer should have a higher percentage of chlorine 35. And if you're lucky enough, A, B, C, D, there's only one answer with a higher chlorine 35. Then you're smart enough, you can get the answer. Okay, I'm teaching you like if you are really very weak, you don't remember the calculation that we have done in class. This is another way for you to figure out the answer as well. Okay, all right. Okay, next, let's continue from where we left off yesterday. Okay, so we mentioned that, okay, we did some examples, okay, on number of mole and then the particles, whether they are atoms, ions, molecules, formula unit. And then the same, okay, if let's say they are molecule, in 1 mole, how many atoms are there? Okay, particles, they can be atoms, they can be molecules, they can be formula units, they can be ions. But you must be specific. Okay, like yesterday, we specified whether carbon is atom or molecule. Whether glucose, is it atom or formula unit? We specified, okay? So you have to be specific. What kind of particle is that? Okay, and then for example, if I have Cl2, okay? Cl2, it can be 1 mole of chlorine molecule. Sorry. Okay. Or it can also be 2 mole of chlorine atom. Okay. That is why your particle, your specific particle is very important because it affects the number in front. Okay, how many it is. Okay, so if let's say I give you an amount, okay, I say that I have 1.02 times 10 to the power of 23 atoms. Okay, I have this amount of atom. How many mole is that? Okay, how do you calculate this? Okay, you know that 1 mole is 6.02 times 10 to the power of 23. All right. So if you have 1.02 times 10 to the power of 23, so how many moles are there? Okay, because you know 1 mole will have 6.02 times 10 to the power of 23. So if you have 1.02 times 10 to the power of 23, how many do you have? So you can cross multiply. Okay. Okay, I think this is quite small here. So I bring it to the whiteboard. Again, I write it clearly. Okay. 1 mole, you have 6.02 times 10 to the power of 23. So if I ask you how many moles are there in 1.02 times 10 to the power of 23? Okay, so this, how many moles you can put as unknown x. This is mathematics, okay? When I give you a certain amount, how do you calculate this value x? You can cross multiply mathematics, okay? And then you will get x. What is x? I don't want the answer, I want the working. How do you get x? 23 divided by 6.02 times 10 to the power of 23. Okay, so this part here represents number of mole. To calculate number of mole, you can use how many particles that you have divided by your Avogadro's constant. Okay, so this represents the formula at the bottom. If you want to calculate number of mole, you can use how many particles you have divided by Avogadro's constant. Okay, all right, so this is also a box. So maybe you want to take note of this. Okay, next, the relation between number of mole and the mass. Okay, if you have the mass, how do you calculate number of mole? This is actually a formula that you have been using for many times, okay? In your secondary school or before coming to foundation. Anyone remember how do you relate, okay, number of mole and mass? Okay, the mass over molar mass formula. Okay, to calculate number of mole, okay, the first formula to calculate number of mole, you use the mass that you have divided by the molar mass. Okay, the mass that you have must be in what unit? Why must it always be in gram? Very good. Molar mass is gram per mole. Okay, that's why you don't blindly memorize formula. Okay, because if you blindly memorize formula, then the mass, if in the question, the mass gives you kilogram, you will just use kilogram. Okay, so why the mass must be in gram? Because the molar mass is gram per mole. So you want to cancel off the gram to get only mole. Therefore, the mass must be in gram, cannot be in kilogram. Okay, put a note there so that you will always remember. If you get some units other than gram, you have to convert to gram. Okay, so whenever we have an equation, okay, so this is what we call a chemical equation. If we have a chemical equation, you know this number in front? Okay, how do you get the numbers in front? Balance, okay? When you balance the equation, you get the number in front. Okay, this number in front, we call it as stoichiometry ratio. Okay, stoichiometry means the chemical equation. Okay, and then the ratio means the number that you have in front after you balance. Okay, so this stoichiometry ratio here can be used to represent the number of mole. What do I mean? Okay, when I write this equation here, 2 mg plus O2 equals to, will produce, okay, 2 MgO. How do I interpret this equation? How do you read this equation? 2 mole of magnesium, okay, reacts with, okay, 1 mole of oxygen gas. Continue. To produce, okay, 2 mole of magnesium oxide. Okay, so what is the reason? Why do you need to balance the equation? Because the balancing gives you an idea how many moles are there in relation. Okay, so you will get the ratio 2 moles in ratio of 1. Okay, 2 moles of magnesium will react with 1 mole of oxygen. Okay, and this will be very important when you do your calculations later. Okay, so this is stoichiometry ratio, and whenever you have an equation, you must balance it first. Okay, any questions so far? No. Okay, let's try exercise. Okay, early in the morning, maybe you are a bit sleepy. So let's try some exercises to wake you up. Okay, this one, the first question, very simple, very direct. How many moles of sodium chloride are there in 117 grams of sodium chloride? Okay, what do you use? Okay, so again, hashtag means number, okay? And the symbol number of mole, N. Okay, so how do you solve this? Okay, what is it that you use? Number of mole, how do you calculate number of mole? Mass over molar mass. Okay, so the mass that you have is it in gram? Double check. Okay, it must be in gram divided by molar mass. What molar mass are you using? Molar mass of what? Sodium chloride. Okay, so what is sodium? 22.99. According to the periodic table, remember yesterday we learned to read the molar mass. We learned to read relative atomic masses. Okay, what about chlorine? Okay, 4.5. Very good. Okay, so what do you get? What do you get? What's the answer? Oh, no one got the answer yet. Exactly 2? Okay, 2.002. Okay, whether if you want to write 2.002 correct, okay, you want to write 2 also correct. But if possible, I encourage you, okay, if there are values behind the decimal points, please write it so that your answer will be as accurate as possible. Okay, is this the answer? No, okay, what else? Some of you was shaking your head. So what else? Very good, mole. You must have the unit, okay? Class, I would like to remind you, if you don't have the unit, you will lose 0.5 marks for the unit. So make sure you have the unit, okay? How do you know the unit is mole? Because you are looking for number of mole. Okay, can you guys try? Is there any further questions? 6. Okay, try question 6. Okay, I give you guys try this first, okay? And then we will see how many. Okay, we are dealing with real chemistry question now. Okay, so I have magnesium burns in oxygen to form magnesium oxide. If you are lucky, the question will give you the equation. If you are not very lucky, you will need to write the equation yourself and balance the equation. Okay, so calculate the mass of magnesium. So let me just highlight, okay, whenever you get a question, make sure you understand the question. So the question is, I need to calculate the mass of magnesium to produce magnesium oxide. So this is magnesium oxide, 65.1 gram. Okay, so how do you start with this question? What do you need to find first? Okay, yes, okay. First, because the only information that you have is the information of magnesium oxide. So you need to think of what to do with magnesium oxide. Magnesium oxide, you have the mass and you know the identity. Okay, if you have the mass and you know what is the chemical formula of the compound, you will be able to find the number of mole. Okay, because number of mole is mass over molar mass. Okay, you have the mass, you know the identity, you know the formula, then you can find the number of mole. Okay, MgO.
65.1 by the
Okay,
mass.
yes, by the molar mass. So magnesium 24.31, oxygen 16. Okay, so what do you get? The first one, number of mole. Again?
The answer is 39.26.
Okay, 39.30. You mean the molar mass?
No, the answer.
The number of mole.
Oh.
Okay, what's the number of mole of magnesium oxide, class? 1.615. Thank you. Is that all? Mole. Okay, must also have the unit. Okay, 1.615. Okay, again, thank you. Okay, you have to put in some values after the decimal points. Okay, don't directly round it up to 2, or your answers will not be accurate. Okay, so we start from here, we continue from here, 1.615. Okay, next, you look at the equation, you look at the question, okay? You have magnesium oxide, you need to find magnesium. So you just close your eyes to all the others. Okay, what do I mean? So you have magnesium and you have magnesium oxide. Okay, what is the ratio in the equation? Magnesium is 2. Magnesium oxide is 2. Okay, it means that if I have 2 mole of magnesium, I will have 2 moles of magnesium oxide. They are the same. Okay, so what about in the calculation? What is the number of mole of magnesium oxide that you have? 1.615 mole. All right. So if you have 1.615 mole, how many mole of magnesium do you have? Also 1.615. How do you know? Because they are the same ratio. So if I have the same number of mole, 1.615, magnesium will also have 1.615. Okay. Do you need to care about oxygen? No, it's not in the question. Okay. So I repeat, okay, when you have questions like this, what do you do? Number 1, okay, look for the information that you have, highlight it, put it in the question, because sometimes the question will be very long. Okay, put it in the equation. Second, figure out from the information that you have, what can you calculate? You have the mass, you can calculate number of mole. Okay, and then third, okay, highlight the information that you have and what you need to find. So you already shorten your view to only magnesium and magnesium oxide. Okay, and then in the equation, the number of mole is 2, 2. The ratio is 2 mole produce 2 mole. Hence, from your calculation, if you have 1.615 mole of magnesium oxide, you should also have 1.615 mole of magnesium. Okay, is this the answer or do you need to have further working? What is the question? The question asks for mass, okay? But what you have now? Number of mole, okay? So how do you do? What do you have to do?
We multiply the number of moles by the atom.
Okay, very good. To those of you who are quick enough, you know what to do, okay? But those of you who can't catch it, so you know that number of mole is mass over molar mass. You have the number of mole of magnesium is 1.615. You need to find the mass of magnesium. And what is the molar mass of magnesium? 24.31. Okay, so how do you calculate the mass? Okay, so mathematically, mass is equals to 1.615 multiplied 24.31. Okay, so what do you get for the mass? Okay, can somebody double check? 39.26. Okay, okay, is that all? Yes, gram. Must have the unit. Okay, so let me label. So first, you calculate number of mole of magnesium oxide. Second, compare with the equation, the stoichiometry. And third, you solve the question. Okay, all right, anything you want to clarify? Good. Okay, I want you to try question 7 and 8. Okay, since 7 and 8 is also utilizing the stoichiometry, try question 7 and 8. Question 6, I already give you an idea how to do. So try 7 and 8. I'll walk around. If you have any question, you can raise up your hand. Okay, but if you choose to just sit down there and wait for people to approach you, I can't read that in your mind. Okay, so try. If you have anything you don't understand, you can raise up your hand when I'm talking to you. Okay, anyone has any problem solving question 7? Any of you have solved question 7? I want to know how many able to solve on your own question 7. Just raise up your hand. Okay, good. Yes?
Can or cannot?
Can. Okay, can. Okay, how many of you cannot solve question 7? Raise up your hand. You know, okay, oh, okay, very good, okay. I really thank students who admit, okay, because if no one raise up your hand, I'll just skip to the next question. Okay, those who can, okay, you can continue, okay. Those who cannot, I'll provide some explanation, okay. So I have iron trioxide, okay. Which of this is iron trioxide? Okay, what does iron 3 means? Iron 3, what is iron? What's the symbol of iron? Fe. Okay, what does the 3 means? It means that it has a 3 positive charge. Okay, that's why iron 3 positive charge. Okay, what is oxide? Oxygen, O. Okay, what's the charge of O? What's the charge of O? Okay, what is the group of oxygen in your periodic table? Which group is oxygen? 16, okay, group 16. So if oxygen is in group 16, it means that how many valence electron does it have? Or do you remember? Okay, you know how to read periodic table? Okay, okay, if it is in group 16, how many valence electron? 6. If it is in group 1, how many valence electron? 1. Okay, so if it is in group 15, how many valence electron? 5. Okay, so oxygen in group 16, so how many valence electron? 6 electrons. Okay, so when you form bonds, okay, what is it that you want to achieve? You form bonds, covalent bonds, ionic bond. What is it that you want to achieve when you form bonds? Stable configuration. Okay, so what does stable configuration means? How many electrons? 8 electrons, 8 valence electron. Okay, or in the case of hydrogen, it will be 2 lah, 2 valence electron. So if you remember this phrase, it's called octet. Okay, and this will be called duplet. Okay, when you have 6 electrons, how to achieve 8 electrons? You have to take in 2 electrons. Okay, so when you take in 2 electrons, so what is the charge that you have? 2 negative. Because you take in extra 2 electrons, the charge will be 2 negative. Okay, so back to here, 2 negative. Remember yesterday I taught you guys how to write chemical formula? So what do you think is a chemical formula of this? Okay, when you have the charge here, okay, when you have the charge already, so what do you do to the charge? Cross. Okay, so iron has 3, so the 3 will give to oxygen. Oxygen has a charge of 2, so this 2 will give to iron. Okay, so again, what is iron trioxide? What is iron trioxide? Okay, what molecule? It's not molecule actually, it's formula unit. Okay, so what is iron trioxide? Fe2O3. Okay, why am I going such a long length? Because I want you to know how to identify what is what. Okay, only then you can start. Okay, so back to here, Fe2O3 plus 3CO produce 2Fe plus 3CO2. Okay, so calculate the maximum mass of iron produced. Okay, which one is iron?
2 Fe.
Okay, Fe. You need to know the identity of each of it. Okay, when you have 798 grams of iron 3 oxide, which one is iron 3 oxide? Fe2O3. Okay, and how much of Fe2O3 do you have? 798 grams. Okay, when you have 798 grams of Fe2O3, how much of iron is produced? The other information, you can close your eyes. That's why I'm teaching you to put in the values in the equation. Okay, all those reduced by excess carbon monoxide is just for your information. It's not required in the calculation, so you can try to ignore it. Okay, so if you have the mass of iron 2 oxide, what do you do? Okay, you can find the number of mole. Okay, and how do you find the number of mole? You use the mass divided by molar mass. Okay, anyone molar mass of iron 2 oxide? 0.7. Others? 159.7. Okay, so what do you get for the number of mole?
Around 5, but 4.9.
Yes, I want the point. Please give me the point. 4.99? 997. Okay, 997 mole. Okay, so you solve this first part. Okay, and then the second part, remember, okay, goes to the stoichiometry. So what you have highlighted, you have Fe2O3, and then you have Fe. Okay, so first, according to the equation, the equation must be balanced equation. According to the balanced equation, how many mole of iron 3 oxide are there? Okay, thank you. So how many mole of iron? 2. Okay, according to your calculation, how many mole of iron 3 oxide do you have? 4.997 mole. Okay, this is a ratio of 1 to 2. If 1 mole equivalent to 4.997, what does 2 moles mean? Oh, how do you get it? 2 times 4.997.
We have most of the iron atom, the first part, and 2 most of the iron atom in the second.
Okay, we're not talking about iron atom. We're talking about the whole thing. Okay, that's why I say look at the ratio. Okay, because 798 is for the whole thing, the ratio of the whole iron 3 oxide. Okay, so we are not talking about only the iron atom. We have 2 iron atom, 2 iron atom. No. Okay, no. So we must look at the whole ratio. That's why I say the equation, the ratio is 1 to 2. So if 1 is equals to 4.997, so 2 will be equals to 2 multiplied by 4.997. Okay, so what's the number of mole of iron? 9.994. Okay, so don't forget mole. Okay, is that all? What's the next one?
We divided by the small atom.
Okay, multiply by the molar mass because the question asks for the mass. Okay, you have the number of moles. So the next step, this is 1, this is 2. So the next step is to find the mass. Okay, number of mole is mass over molar mass. So mass will be your number of mole multiplied by the molar mass. Iron, 55.85. Okay, so what do you get?
558.15.
0.15? 16. 164
165.
or 165. Okay, gram.
I just used the when I calculated the amount.
Okay, you can use 558.17. You can use 558.2. Acceptable. As long as after the decimal point, you must have some values. Okay, any question? Anything you guys want to clarify? Anyone? Okay, good. Okay, question 8. How many of you able to solve it? Put up your hand. Okay, very good. How many cannot solve question 8? Put up your hand. Okay, I think after question 7, okay, maybe you guys have some idea how to solve question 8. I'll just quickly go through this, okay, because we are a bit lag behind, okay? We spend too much time discussing. Okay, so again, tin 4 oxide, okay? Let's quickly try to figure out what is tin 2 oxide. Okay, what is tin? Strontium, Sn. Okay, so 4, what does 4 means again? The charge is 4 positive. Okay, iron 3 is 3 positive. So tin 4, okay, is 4 positive. Okay, and then oxide, 2 negative. Okay, so the formula will be what will be the formula? Sn2O4, but you will have to simplify, okay, the charges. So what will it be? SnO2. Okay, so it's referring to tin 2 oxide. Okay, and then the rest are reduced by, and then carbon monoxide is also formed. So carbon monoxide here. Okay, calculate the mass of carbon. Okay, so I highlight because in the question I have carbon and I need to find the mass. Okay, calculate the mass of carbon that exactly reacts with 14 grams of tin 4 oxide. So I have 14 grams of tin 4 oxide. Okay, this question, it has a specific requirement. 3 significant figures. So we just highlight it and put it later. Okay, when we finish, we have to double check. Okay, now I have the mass, I have the identity. So first, what do you calculate? Number of mole. Okay, whenever you have the mass, you know what is the chemical. What is the chemical formula? You calculate number of mole. Okay, number of mole is mass over molar mass. Can somebody give me the molar mass? Anyone? 1, or what's that? Correct? Okay, thank you. So what's the number of mole? 0.0929. Okay, thank you. 29 mole. Okay, by giving me answers, you are helping to speed up the process. Okay, so here again, we have tin 4 oxide, SnO2, and we have carbon. We're talking about these two. So according to the equation, what is the ratio? 1 to 2. Okay, 1 mole of tin 4 oxide and 2 moles of carbon. So according to your calculation, okay, you have 0.0929 of tin 4 oxide. So how many moles of carbon do you have? Thank you. 2 multiply 0.0929, so equals to 0.1858. Okay, mole. Okay, and then once you have the mole, can you calculate the mass? Okay. Okay, so mass, you multiply the number of mole by the molar mass of carbon. So carbon is 12.01. So what do you get? 2.23 grams. Okay. Sorry, question 7 and 8, I have to speed up a bit. Okay. All right. Any question? If you really, okay, I prefer, if possible, okay, if you face any obstacles, if you really can't solve anything, you directly ask after the class. Okay. If you don't want to come directly now or after the class, you can text me in Microsoft Teams. I can explain to you. If not, okay, you accumulate everything that you don't understand, and then towards the semester, it will be a whole mountain of things that you don't understand. Okay, all right. I want to go through one part before I let you guys for a break. Okay, I'll give you a 10 minutes break, but let's finish this part first. Okay, let's say I have water. Okay, so water is H2O. And I want to know, okay, what is the percentage composition, okay, of hydrogen in water? Okay, what does it mean by percentage composition? Okay, percentage, of course, you know, is a percent. Composition means, okay, I have a whole compound. How much of the compound consists, okay, of hydrogen? Okay, because this water is made up of oxygen and hydrogen. I want to know the composition. How much is hydrogen? That is the percentage. This is what we call percentage composition of hydrogen. Okay, so how do you go around this? If I want to know how much of hydrogen are there, how do you calculate? Okay, calculate the mass of each atom of everything. Okay, I want to know hydrogen. So how?
We divide the mass of hydrogen atoms by the mass of the whole molecule and multiply it by 100%.
Okay, whole molecule multiplied by 100%. Okay, because we have two hydrogen, so each hydrogen has their own mass. I use the mass of hydrogen divided by the whole mass. Then I know composition, how much of hydrogen is in everything. Okay, and then I multiply by 100. Okay, so this is the next part that we are learning. Percentage composition by mass, by using the mass. Okay, we can use the relative atomic mass, the masses of the atom, to calculate the percentage mass of a particular element. Do you remember I mentioned what is element? Element means anything in the periodic table. Big business, huh? Okay, handphones are all the time. Okay, all right, so element means anything in the periodic table. If I say I want the mass of hydrogen, then you use the relative atomic mass of hydrogen. Okay, so of a particular element in a compound. Compound means a mixture. In a mixture, I want how much of this element. Okay, suppose that A is the element. If I want the percentage composition of A, I will use the mass of A divided by the mass of everything, the whole compound, multiplied by 100 to get the percentage. Okay, so that's why we learn, okay, we understand first what is composition. In a whole compound, if I want only one single part, I use the mass of that single part divided by the total mass times 100%. Okay, all right, let's try one question with all of you. Then I'll let you guys go for a break. Okay, a short break. Okay, calculate the percentage by mass of iron. What is iron? Fe. Okay, in iron 3 oxide, Fe2O3. All right, so percentage by mass of iron will be my mass of iron. So what is the mass of iron? Okay, do I just use 55.85?
We multiply it by 2 atoms.
Yes, okay, multiply by 2 because in the compound, I have 2 iron. So I need to multiply by 2. Okay, and then divided by the total mass. So total, I have 2 iron. plus with 3 oxygen. Okay.
Like,
Yes, and you multiply it by 100. Okay, so what do you get? Exactly? Exactly 69.9? 69.94. Okay. 69.94. Is that all? 9434. Okay, 36. Is that all? Okay. The important thing is the percent. Okay, whether you put 69.9, 69.94, okay, you need the percent. All right, I'll give you guys a 10 minutes break. It is 9:57, so we will come back at 10:07, okay, and to continue. Okay, during your break, you can try question 10, okay, so, and then we will continue from there. Okay, you can go for a break. You guys can go toilet, or you can go for a break. You want to talk to friends, you want to get buy snacks, okay? What's your name,
Alex.
Alex. Go wash your hand, Alex. Thanks, Alex. I'm using the attendance, so please pass it around. All right, one more minute, we will start. All right, 10:07. Okay, get yourself ready. We shall start. Okay, so percentage of carbon in methanol. Okay, so we have how many carbons are there? 2. Okay, so you have to multiply 2 carbon, 12.01, and then divided by the total mass. Anyone has calculated the total mass? Okay, I'll just use the total mass. Yes? What? 46.08. Okay, so add on everything and then multiply by 100%. So what do you get? 13. Okay, very good. All right, 52.13%. Okay, so this answer over here is for a guidance. Okay, so your answer will be more or less to that answer. Okay, so let's continue. Okay, why we learn? I think there is somebody who turn on the voice, okay, of your recording of Microsoft Teams. Okay, is it off? Okay, so anyone who joined Microsoft Teams and you turn on the volume, because I heard echo. No, I didn't. Okay, so why do we learn about percentage composition by mass? Okay, I still hear echo. Let me.
How could this be? What is happening? Why got echo?
All right, so why do we learn about percentage composition by mass? Okay, because we are going next into empirical formula and molecular formula. Okay, so what is empirical formula? Okay, empirical formula means, okay, the simplest ratio, the simplest formula. Okay, the formula of the compound when I write in the smallest integer, or what I call simplest ratio. Okay, but the ratio must be in the form of a whole number, must be integer. It means that I cannot have C 1.5, H 2.5, cannot. Okay, it must be in a whole number. So that is empirical, the simple one. Okay, molecular formula means the real formula. Okay, so the real formula could be C2H4, the real formula. But if I want to write my molecular formula into empirical formula, the simplest ratio, it will become CH2. Okay, so this is the difference between empirical and the molecular formula. Okay, if I have the empirical formula, I have the molar mass or the relative molecular mass, I can find the molecular formula. So we will look into this later. Okay, so for example, okay, I have molecular formula C2H2. I have molecular formula C6H6. Both of these are actually different compound, different molecule. But if I write them in the form of empirical formula, they look the same. Okay, both of these in the simple form is also CH. So maybe, okay, if we just use empirical formula, people might get confused. This is CH, this is CH. So you don't know the exact molecule, you will get a different property. You will be confused with the property. So we have to find what is the molecular formula, what is the real formula. Okay, let me move to the whiteboard, okay, and do some examples. Okay, I prefer to write it in the board, okay, rather than following the step-by-step guide. Okay, when I have 1.55 gram of phosphorus. So first I have phosphorus. It's being completely combusted. What does combusted means? Burn in oxygen. Okay, combustion means burning in oxygen. Okay, I will produce oxide of phosphorus. What does oxide of phosphorus means? Phosphorus with oxygen. Okay, but we don't know the formula. Phosphorus of oxygen. Okay, deduce the empirical formula of this oxide. So this oxide will have phosphorus and oxygen. So I have phosphorus, I have oxygen. I need to deduce what is the formula. Okay, so what is the information that I have? Okay, what mass do you have? Okay, mass of phosphorus is 1.55 gram. Okay, when you burn phosphorus and oxygen together, you get phosphorus oxide, which is 3.55 gram. PXOY, phosphorus oxide is 3.55 gram. Phosphorus is 1.55 gram. What is the mass of oxygen? 2. Okay, teacher, why? Okay, because when you have only this substance reacting, producing a product which consists of exactly the same element, then the mass must be the same. Okay, so let's say you have 1.55 gram of phosphorus. Then the phosphorus here in your phosphorus oxide will also be 1.55 gram. So how much of oxygen are there? 2 gram. Okay, 3.55 minus 1.55, 2 gram. Okay, when you have the mass, let's focus on the table. When you have the mass, what can you find next? The mole. Okay, so again, as I mentioned, you have the mass, you know the identity, find the number of mole. Okay, number of mole is mass over molar mass. Okay, how many moles do you get?
0.05. 0.05.
Thank you. 0.05 mole. What about oxygen?
0.125.
125. Okay, you have the respective number of mole. How do you find the simplest ratio? Because empirical formula means the simplest ratio. You have 0.05, you have 0.125. So how do you find the simplest ratio? Why you divide by 0.05? Why not divide by 0.125?
0.0 smaller than 0.
Okay, divide by the smallest. Okay, you need to find the smallest integer. So you compare between these two answers that you have, which is the smallest? 0.05. Okay, so both also, to find the ratio, both also divide by 0.05. This one is 0.125, divide by 0.05. This will give you 1, this will give you
2.5.
2.5. Okay, so let's say, can this answer be accepted?
No.
Why not?
Decimal.
Must be integer. Very good. Okay, so you guys understand. So how do you change it to integer?
Times 10.
Multiply by 2, and both sides also you have to multiply by 2. Okay, so this will give you 2, this will give you 5. So what is your empirical formula? Yes, P2O5.
25.
Okay, all right, give you 1 minute. Okay, tidy up your note and try to understand this. Then we move on to the second example. Okay, so for calculating empirical formula, the steps will be the same. Okay, so first you have the information, mass. And from the mass, what can you look for? Number of mole. Mass divided by molar mass, you get the number of mole. And then because empirical formula is the simplest ratio. So how do you find the ratio? Divide by the smallest number. Okay, and then you get the ratio. If the ratio is not in whole number, you have to convert it into whole number. All right, any question?
Nope.
Okay, good.
The patient supply of AC or example.
Okay, proceed to the second example, okay, which is by percentage. Okay, just now we use by mass. Now we use by percentage. Okay, let's see whether is there any difference. I have a compound, okay? A compound, as I mentioned yesterday, it can be molecule, it can be ionic compound. Okay, so I have a compound, a mixture, okay, of more than one atom. I have a compound consisting of carbon and hydrogen. So this compound consists of carbon and hydrogen. I give you the percentage. Carbon is 85.7%. Hydrogen is 14.3%. Okay, and I tell you here, it is percentage by mass. Okay, deduce the empirical formula. My first question, can I use the percentage and I assume that it is the mass?
Yes.
Okay, percentage by mass. Can I use the percentage and I assume it represents the mass as well?
Yes.
Why yes?
我讲 yes 的，还真的是
Okay,
yes 的。
because you want the ratio. We are looking at the ratio of the mole, the simplest ratio. And we learned just now, percentage composition by mass. We actually use the mass divided by total mass to get the percentage, okay? So actually, yes, we can assume it as the mass and we calculate the number of moles from this percentage. Okay, just use according to as if it is the mass. It symbolizes the mass. So 85.7 divided by 12.01. 14.3 divided by 1.01. Okay, my next question. Do I need to divide by 1.01 or 1.01 multiplied by 2?
No, 2.
Because you know hydrogen, you always know that hydrogen is a gas molecule. So gas always comes with 2 atoms, gas molecule. So my question is, do you divide by 1.01 or 1.01 multiplied by 2?
1.01.
How many of you say 1.01? How many of you say 1.01 multiplied by 2? Okay, I hope you guys know why it is 1.01. Okay, because if you multiply by 2, it means that the ratio that you have later, let's say the ratio that you have later is 2 and 5. Then you have to put this C2, H2, 5. Okay, because you divide by this as H2, so it will be H2 here. But you don't want to confuse yourself. You want to directly put this as an integer. You want to find what is your Y. So please use an atom. Okay, so that whatever ratio that you get here, you can directly substitute inside what is H. Okay, so don't divide by 2. Okay, if you divide by 2, you are already assuming it is a H2. Okay, so what do you get here?
7.135.
135.
7.136.
Okay, 7.136. And this one?
14.158.
14.158. Can somebody check? Correct? Okay. Thank you. Okay, so once you get the number of mole, find the ratio. Which is the smallest? 7.136. Okay, so both also divide by 7.136.
One to two.
Yeah. Just better than some.
Okay, so what do you get? 1 and
1.9.
1.984. Okay, for ratio, okay, empirical formula ratio, when you get values as close as this 1.9 something, 9998, okay,
Round up.
you can actually round it to the nearest. Okay, rather than you need to multiply it to get the whole number. So you can actually, because it's very, very near to a whole number, you can round it to the nearest whole number. Okay, so what do you get? What is your empirical formula? H2. Okay, do you need to write the 1? No.
No.
Okay, CH2.
One, right?
Okay, give you 1 minute, tidy up your calculations or notes, then we move on to the next part, how we use empirical formula to calculate molecular formula. Okay, what is empirical formula? Simplest ratio. Okay, what is molecular formula? The actual formula. Okay, so now I have empirical formula CH2Br. Okay, and I tell you that this compound, the relative molecular mass is 187.8. My first question, 187.8 is the molar mass, the molecular, the RMM, relative molecular mass of the empirical formula or of the molecular formula? Yes, okay, this is the molecular formula. This is the mass for the real mass for the molecular formula. Okay, empirical formula is the shortened, the simple ratio. Okay, and the ratio was we divided it by something, we factorized it, we simplified it. So how much we simplified, we put an unknown. We want to find how much we have simplified the formula. Okay, and then the real formula will give us this mass, 187.8. Okay, shall we find the empirical formula? What is the mass of the empirical formula first?
93.9.
Oh, so fast. Somebody just double check, 93.93, is it? Okay, so 93.93. Empirical formula has the mass of 93.93. Molecular formula has the mass of 187.8. I want to know how much has been simplified. So how much has been simplified? Uh, 1.999, so it's roughly 2. Correct? That means my empirical formula has been simplified by 2 times. Okay, so how do you find the molecular formula, class?
We divide the
Divide times multiply, okay? Because your empirical formula, you figure out that it has been simplified by 2 times. Okay, so your molecular formula will be multiply inside C2H4Br2. Okay, C2H4Br2. So this is how you get the molecular formula from the empirical formula. Okay, I think there is one example. Okay, can you guys try question 11? Okay. Okay, if you have gotten the answer for question 11, you can raise up your hand. So at least I know if around half of the class has gotten the answer, then I can start the discussion. Okay, so this one, you have the percentage of carbon, percentage of hydrogen, percentage of oxygen, percentage of nitrogen. This is quite a long empirical formula. Okay, you have 4 percentages. And I tell you that the molar mass is 194.19. What is the molecular formula? So it involves multiple steps. First, you have to find from the percentages what is the empirical formula. And then from the empirical formula, you find what is the molecular formula. Okay? Okay, you have carbon, you have hydrogen, you have oxygen, you have nitrogen. Okay, anyone calculated the number of mole? Okay, I won't be doing the step by step. Anyone calculated the number of mole? Okay, how many? Carbon is 4.1, 2. Okay, and then this one? 5.13. What is it?
5.14.
5 or 4? 5.13. Okay, 14 lah. All right, 139. Okay, what about oxygen? 1.03. Nitrogen? 2.06. 2.06. Okay. All right, so find the ratio. Okay, so which is the smallest number? 1.03. Okay, let's try to divide everything by 1.03. Uh, 4.99, right, for hydrogen. Okay, so let's round it to 5 because it's 4.99. And then this one is? Okay, so what's the empirical formula? C4H5O1 and 2. Okay, so this is the empirical formula. You want to find how many times, okay, it has been simplified to get the molar mass, the relative molecular mass of 194.19. So what is your molar mass for your empirical formula? Is it 87.11 or 97? Oh, okay, 16. Okay, thank you. 97.11. will give you 194.19. So what is your N? 2. So what is your molecular formula? C8, H10, O2, and 4. Okay. All right. So these are among the easier, okay, questions in chapter 1. Okay. So I hope you guys are able to do it. If you are struggling, please seek help. Okay. Don't just sit there. Okay. Last part. Okay. Just to check your understanding. Okay. Before I let you go. Okay. Your friend has some questions about empirical formula and molecular formula. Okay, so for the first question, he has this answer. Is this answer correct as an empirical formula? If no, what will you tell your friend? Is this correct as an empirical formula? Why? It must be in the simplest ratio. So what's the correct answer? Okay, CH4O. Okay, for another question, your friend came up with this, C1.5H4 as the empirical formula. Is this correct or not? Okay, why again? Must be integer, must be whole number. So what is the correct answer? Okay, you have to put this as an integer, so you multiply by 2. Okay, so lastly, okay, just reminder, chemistry assignment, I try my best and see if I can release it on Friday, okay? If I release on Friday, I will upload in Microsoft Teams. It will be in the form of a recording. Why do I do recording? Okay, because normally if I brief in the class, students will be sleeping. Too much of information. Okay, they'll be very bored with all the information and then they don't understand. Okay, so I will release in recording part by part. Okay, for example, this assignment, how many minutes? This assignment, how many minutes? So you can go through the recording whenever you need. Okay, whichever part that you think you need help, you want to seek for the instructions, you can watch the recording for that part. Okay, can you give me around 2 more minutes, okay? Because I know if you're packing, you're not listening. Oh, you haven't signed. Okay. All right, the groups, okay, how many person per group? It will be 5 to 6 students. Okay, you can start to find members, but then, okay, I will have a limit. How many group 5, how many group 6? But I cannot tell you now because I haven't get the finalized number of students. Okay, when I get finalized number of students, I think by end of next week or in week 3, then I will post out an Excel, okay? How many groups 5 students, how many group 6 students, then you can put your names in. But to be safe, okay, just find 5 first because I don't want everyone to find 6 members and then suddenly there are 2 students without members. Okay, so you can start to find a few friends, no problem. Okay, and then what is group contract? I will mention in the assignment briefing. Don't worry, okay, nothing complicated. And then the topics also, okay, I will mention in the briefing. Okay, lastly, 1 minute. 1 minute, okay? I have posted an announcement. Class, 1 minute, please. Okay, I posted this announcement because number 1, I noticed not everyone attended the lab induction yesterday. And number 2, okay, when the lab assistant was talking about lab coat, you guys were looking for attendance, okay, sending in the declaration form. So everyone was quite busy. Okay, so I posted here regarding your lab coat. I want to remind, no lab coat cannot enter lab. Okay, so please get ready your lab coat before your practical sessions. So how can you get the lab coats? I have all the instructions here. If you have any question, you can PM me, you can chat with me, okay? But please, as I mentioned, a lot of announcements in Microsoft Teams, so please check Microsoft Teams, okay? All right, that's all for today. Thank you, class. Have a nice day. I'll see you guys next week.